For question 1, the lower bound of 2.75 to 2 decimal places is 2.745. For question 2, let's start with the left-hand side. I'm going to write these two fractions with a common denominator. So this is 5 and 7 over 21 minus 2 and 18 over 21. I'm going to convert the first fraction into 4 and 28 over 21. I'll keep the second one the same. Subtracting the integer parts will give me 2. Subtracting the fractional parts will give me 10 over 21. And this is equal to the right-hand side. In question 3, we're given that the probability of landing on 2 and landing on 4 are equal. Let's call both of these x. In order to find x, I'll create an equation. The sum of all the probabilities is equal to 1. So 0.26 plus x plus 0.18 plus x must be equal to 1. So 2x plus 0.44 is equal to 1. 2x is equal to 0.56, so x is equal to 0.28. Let's write this on the table as well. So now probability of getting 1 or 2 is equal to 0.26 plus 0.28, which gives me 0.54. So the expected number of times we'll get 1 or 2 is equal to 250 times this probability, which gives me 135. For part A of question 4, if we expand, we get n squared plus 4n minus 6n minus 24. Collecting like terms will give me n squared minus 2n minus 24. For part B, let's start by cross multiplying. 4 times 2x minus 3 is equal to 3x minus 5. Now let's expand. 8x minus 12 is equal to 3x minus 5. I'll take all the x's to the left and get 5x, and then everything else on the right will give me 7. So x is 7 over 5. For question 5, speed is equal to distance over time. Distance is 3,980. And now the time is 5 hours and 24 over 60, because those are minutes. Now if you put this on the calculator, you'll get 737 kilometers per hour. Now note this time here, if you want to convert it as a decimal, is not 5.24. That's a common mistake students make. The correct answer is 3,980 over 5.4. And the reason is that 5 and 24 over 60 simplifies to 5 and 2 over 5, or if you want, 5 and 4 over 10. I will start question 6 by dividing the shape into a rectangle and a trapezium. Now the area for the rectangle is simple, it's base times height, or length times width. Let's focus on the trapezium. Let's extract it here below. Now the height of the trapezium is 20, which is the height of the whole shape, minus 12, which is the height of the rectangle. So this is an 8. And now I'm given that the total area is 434. So the area of the rectangle plus the area of the trapezium is equal to this number. The formula for the area of the trapezium is given, and it's the following. So let's create an equation. 12 times 28 for the rectangle plus 18 plus Cindy times 8 over 2 is equal to 434. Let's simplify the 2 with the 8. So 336 plus, and I'm going to expand, 72 plus 4 times Cindy is equal to 434. 4 Cindy is equal to 26. So Cindy comes out to be 6.5. For part A of question 7, anything to the power of 0 is 1. So this is 8 times 1, which is just 8. In part B, the rule says that you have division, you subtract the powers, so we have x to the power of 6 minus minus 5, so you get x to the power of 11, which means p is 11. For part C, the power outside the bracket 3 applies to each one of the three factors, so this will give me 2 to the power of 3 times k squared to the power of 3 times m to the 4 to the power of 3. 2 to the power of 3 is an 8, and then for the other two, I will multiply the powers. So this will give me k to the power of 6 times m to the power of 12. For question 8, 81 kilometers per hour means 81 kilometers over 1 hour. Let's convert each one separately. So for the kilometers, to be converted into meters, I'm going to multiply by 1,000. For the hour, I need to multiply by 60 to make it into minutes, and then times another 60 to make it into seconds. So this is meter per second. Put this on the calculator and you will get 22.5. For 9a, 3 times 4 is equal to 12. Then for the a's, add the power. This will give you a to the 11. The same with b, add the powers, and you'll get b to the power of 7. For part B, common factors are 7x squared and y squared, and then you are left with 2y squared plus 3x. For part C, I'm going to take 2 points on the line. I've taken those two, but you can take any 2 points. So the formula for the gradient is the following. Let's plug in the values. 4 minus 0 over 0 minus 2 will give me minus 2. Now the y-intercept, you can see this from the graph, it's this point, so the y-intercept is 4. So the equation is y equals minus 2x plus 4. Finally, for part D, we want the y-intercept of this graph, of this equation. Now the y-intercept is the constant that doesn't have an x, and this is a minus 5. Full coordinates 0, minus 5. For question 10, I have two right angle triangles. Now to find A and B, I'll use Pythagoras theorem and the blue triangle. So AB squared is equal to 7.5 squared minus 6 squared. This is equal to 20.25. Take the square root of that, so A and B comes out to be 4.5. Now the area of triangle ABC, which is the blue triangle, is equal to 6 times 4.5 over 2, which is equal to 13.5. So the area of AC and D, which is the red triangle, is the area of the whole shape minus the area of the blue triangle, and this is 18. So for the red triangle, base times height over 2 is equal to 18, which implies that A and D is 18 times 2 over 7.5. Put this on the calculator and you will get 4.8. For question 11, we take a bit and then we keep it, we're not replacing it. So this is without replacement. That's why the denominator is decreasing by 1. So if the first one is blue, then the probability the second one is red is 4 out of 10. And the probability the second one is blue is 6 out of 10. For part B, the probability that both are red is 4 over 11 times 3 over 10, which is 12 over 110. You can simplify this to 6 over 55. For part C, we want the probability that the two bits are different colors. So we have probability of red followed by blue plus probability blue followed by red, which is equal to, and then you have to multiply the probabilities along the branches. So that's 4 over 11 times 7 over 10, or 7 over 11 times 4 over 10. So let's write this down. And this is 28 over 110 plus the same thing, which gives 56 over 110. If you simplify, you'll get 28 over 55. Part A of question 12 is the difference of two squares, so the two factors will be 3x minus 2y and 3x plus 2y. For part B, the lowest common multiple of the denominators is equal to 8x. So I'll multiply the first fraction by x and the second by 2. So I'll get 7x minus 2 times x plus 3 all over 8x. So now let's expand. 7x minus 2x minus 6. Denominator stays the same. And now if I simplify, I'll get 5x minus 6 all over 8x. For 13a, I'll change the order of those two brackets. So I have 3x minus 1, then 3x plus 1, and then x plus 2. And I've done this because the first two brackets, when expanded, will be the difference of two squares. So I have 9x squared minus 1 times x plus 2. So that will make my life easier. So expanding this will give me 9x to the power of 3 plus 18x to the power of 2 minus x minus 2. And that's the final answer for part A. For part B, I'll start by flipping my fraction and changing the power to a positive one. So 8xy to the power of 2 over 2x to the 5 and everything to the power of positive 2. Now we'll simplify the 8 with the 2 and I will also simplify the x's. Cancels out at the top. I'll be left with the power of 4 in the denominator. So let me rewrite this more clearly. 4y squared over x to the 4 and everything to the power of 2. The power of 2 will apply to all terms, so 4 squared will be 16, y squared squared is y to the 4 over x to the power of 8. That's the final answer. For question 14, to complete the Venn diagram, I'll start from the center, coming outwards. So 6 farmers have goats, sheep, and chicken. So I'm going to put a 6 at the center. Then I have 11 farmers with sheep and goats. So this region has 11. So the top one will have a 5. There are 17 farmers with sheep and chicken. So this region here is 17, which makes this an 11. And then I have 18 farmers with goats and chicken. So this region is 18, which makes this a 12. 20 farmers do not have any goats, sheep, or chickens. So there's a 20 outside the 3 circles. And now I have 31 farmers with sheep, which means that this whole region is equal to 31. So this region here is 31 minus 5 minus 6 minus 11. And this is equal to 9. Now 53 farmers have chicken, so this region is equal to 53. So this region only chicken is equal to 53 minus the other 3 numbers. And this comes out to be 24. Finally, there are in total 100 farmers. So to find this region here, which is the only one which I haven't completed yet, I'm going to do 100 minus every other number. And if you do that, you're going to get an answer of 13. In part BI, I want N and G, which means the number of elements, the number of farmers in set G. So I'm going to add all these numbers here. And the answer comes out to be 36. For II, I want the number of farmers in G union S dash. G union S is this region here. So G union S dash is made up of those 2 numbers. Then for II, number of farmers in G dash intersection C. So that's the C without the G. The whole of C is this circle here. The C without the G is this region here. So it's 24 plus 11. In part C, it says one of the farmers who has chickens is chosen at random. Now this is a conditional probability situation. I'm only choosing from the farmers that we know have chickens, so my denominator will be 53. And I want the probability that this farmer also has goats, so let's go to the Venn diagram. So out of those 53 farmers, how many have goats? And the answer is these 12 and 6 farmers. So that's my numerator. And if I simplify, I'll get 18 over 53. The idea behind question 15 is the following. Using the rounded values, Martin's speed is the following, and Lucia's speed is the following. And because Lucia's speed is higher, we're thinking Lucia is going faster. But we are not allowed to use the rounded values. We have to find the upper and lower bounds. Now, the lower bound for Martin's distance is 77.5 and the upper bound is 82.5. For the time, 2.65 and 2.75. For Lucia, distance lower bound is 32.5, upper bound is 33.5, and time is 0.95 and 1.05. Now there's an interval of speeds for Martin and Lucia. If there's no overlap between those intervals, then obviously Lucia's speed is higher. But if there is an overlap, then maybe Martin's speed is more than Lucia's speed. So what we need to do is compare Martin's upper bound with Lucia's lower bound. If Martin's upper bound is greater than Lucia's lower bound, then Martin's is correct in his statement. So let's start by finding Martin's upper bound. So the upper bound for speed is equal to the upper bound for the distance over the lower bound for the time, which is equal to 82.5 over 2.65, which gives me 31.13. And now for Lucia, the lower bound for the speed is equal to the lower bound of the distance over the upper bound of time. This is equal to 32.5 over 1.05. This comes out to be 30.95. So my final conclusion is that since the upper bound for Martin's speed is greater than the lower bound for Lucia's speed, this statement is correct. For question 16, I'm given that there are 10 children with a time of less than 20, which means that the frequency and hence the area of that block is equal to 20, and I'm going to use that to find the height. So if area is equal to 10, then 20 times height is equal to 10, which means height is equal to 0.5. So if I write 0.5 there, I can now complete the whole of the vertical scale. And the question was an estimate for the number of children with times between 50 and 80, so I want the following area. And to do that, I'm going to break this into 3 different rectangles, one between 50 and 60, one between 60 and 75, which is here, and one between 75 and 80. So that area is 10 times 2.9 plus 15 times 3.2 plus 5 times 2. This will give me 29 plus 48 plus 10, which gives me a total of 87. For question 17, I'll start by simplifying the denominator. So for this expression here, let me rewrite it I will have square root of 2 minus 1 times itself. So if I expand, I'll get square root of 2 squared minus square root of 2 minus square root of 2 plus 1. Now square root of 2 squared is just 2 minus 2 root 2 plus 1. So this simplifies to 3 minus 2 root 2. Now I'm going to take the square root of 8 and rewrite this as square root of 4 times square root of 2, which is 2 square root of 2. So the whole of the fraction now is 3 plus 2 square root of 2 over 3 minus 2 square root of 2. And I will rationalize the denominator by multiplying top and bottom by 3 plus 2 square root of 2. So now if I expand, I will get the following: 9 plus 6 square root of 2 plus 6 square root of 2 plus 4 square root of 4 over 9 minus 4 square root of 4. Note that the denominator, once you multiply these two, that's the difference of two squares. Now 4 square root of 4 is the same as 4 times 2, which is equal to 8. Same in the denominator. So if I simplify, I will get 9 plus 8, which is 17, plus 12 square root of 2 over 1. So I can ignore the denominator now. Although this is in its simplest form, the question requires the answer to be in the form p plus square root of q. So this must be merged into a single surd. So let's continue at the bottom. 17 plus, and I'm going to write 12 as square root of 144. I still have the square root of 2. So now I can multiply those two surds into a single surd and have 17 plus square root of 288. And that's the final answer. For question 18, I'll need to create an equation. I know that the shaded area is equal to 20. So it's the area of the rectangle, which is 4x times 2x minus the two circles, so pi r squared twice. But instead of r, I have an x, so 2 pi x squared is equal to 20. So 8x squared minus 2 pi x squared is equal to 20. On the left, I'll factor out the x squared, so x squared 8 minus 2 pi is equal to 20. So x squared is equal to 20 over 8 minus 2 pi. So x is equal to the square root of this expression. Now I can leave this as it is, or if you want, I can write it as a decimal. This is 3.413133592. So to find the perimeter, I will just do 2 times length plus width, which is 2 times 6x, which is equal to 12x. I just found x above, so if you do this multiplication, you'll get 40.957 and so on. Correct to 3 significant figures, this is 41.0. Now, although it says 3 significant figures, if you write 41 in this specific question, the mark scheme accepts it. For question 19, I'll start by extracting some triangles from this 3D shape. The orange triangle is lying flat on the base of this 3D shape, while the red one and the blue one are standing vertically. Note that all 3 of those triangles are right angle triangles. So let's go below and extract them. I'll start from the red triangle and find side AD. So tan of 18 is equal to the opposite, which is 2.2 over the adjacent, which is AD. If I rearrange, AD is 2.2 over tan 18. This comes out to be 6.77. If you want full accuracy, this is what you get. Now that I found AD, I can transfer this on the orange triangle. And using this triangle and Pythagoras theorem, I will find BD. So BD squared is equal to 6 squared plus AD squared. For AD, I'm going to use the full accuracy. And if I rearrange to get BD on its own, I will get 9.04 and more digits. This is the full accuracy. Now I can transfer this on the blue triangle. And using the tan ratio, I can find the angle B. So tan of B is equal to 2.2 over BD. So angle B is the inverse tan of 2.2 over 9.04 and all the rest of the digits. Put this on the calculator and you get 13.7 degrees, correct to 1 decimal place. In question 20, we need to complete the square. And in order to complete the square, I will use the following formula. But before I apply this formula, I need to do 2 steps. First, I'm going to write the expression in descending powers of x. And then the second step, I'm going to take out a common factor of -2 from these 2 terms. So -2, I'm going to have a square bracket, x squared minus 6x, and then plus 7. Note the minus here is because I took a minus outside. When you expand, you should get the plus. So now I'm going to apply that formula in this expression inside the square bracket. So if you complete the square, you get x minus half of 6, which is 3 squared, minus 3 squared, which simplifies to x minus 3 squared minus 9. And I'm going to substitute this back into the square bracket. So I will get minus 2 square bracket, x minus 3 squared minus 9, close the square bracket, plus 7. 2 more steps required. First is to expand the square bracket. So I get minus 2 x minus 3 squared plus 18 plus 7. And the second step is to simplify those 2 constants. I'm going to put that at the front to match the required form. So 25 minus 2 x minus 3 squared. So I have completed the square. I will write down the values of a, b, and c. A is 25, b is equal to 2, and c is equal to 3. For question 21, I'll start with the expression in the bracket. And I will try and simplify this. The denominator of the first fraction is the difference of 2 squares. So I can write it as 20 over x minus 6, x plus 6. The second fraction stays the same. And now the lowest common multiple is x minus 6, x plus 6. So I'll have to multiply the second fraction by x plus 6. So I will have 20 minus 2 times x plus 6. Let's expand the numerator. 20 minus 2x minus 12. And if I simplify this, I'll get 8 minus 2x. Denominator stays the same. And now I will multiply this with the second fraction. So I have 8 minus 2x over x minus 6, x plus 6 times 1 over 4 minus x. Now note, if I factorize this, I will get 2 times 4 minus x. I'm going to keep the denominator the same, x minus 6, x plus 6 times my second fraction. And now I can cross out the 4 minus x. And I'll be left with 2 over x minus 6, x plus 6. Now, you can expand the denominator if you want, but it won't change anything. Both answers are equally acceptable. For question 22, I'll write all the numbers as a product of powers of 2 and 3. So 18 is equal to 2 times 9. So it's 2 times 3 squared. 6 is equal to 2 times 3. 9 is equal to 3 squared. And finally, 27 is equal to 3 to the power of 3. So I'm going to write the fraction on the left-hand side as follows. 2 times 3 to the power of 2 times 3 to the power of 3. And now I have a square root. Square root is a power of a half. And then the whole thing to the power of 4n plus 6. Denominator, instead of 6, I'm going to have 2 times 3. And then instead of 9, I will have 3 squared and everything to the power of 2n plus 8. I will cancel out the 2's. And now we'll apply the laws of powers. I will multiply these two powers and these two powers. This will give me 3 to the power of 2 times 3 to the power of 3 and the whole thing to the power of 2n plus 3. And then in the denominator, 3, that's to the power of 1, times 3 to the power of 4n plus 16. Once more for the numerator, so I can multiply these two powers. This will give me 3 squared times 3 to the 6n plus 9. And in the denominator, 3 to the 1 times 3 to the 4n plus 16. Now the addition law, so I can add those two powers and I will also add those two powers. So I will have 3 to the 6n plus 11 in the numerator and 3 to the 4n plus 17 in the denominator. And finally, I will subtract this power minus this power because of the division. I'll do it step by step. 3 to the 6n plus 11 minus 4n plus 17. So 3 to the 6n plus 11 minus 4n minus 17. And this simplifies to 3 to the power of 2n minus 6. Therefore, x is equal to 2n minus 6. For question 23, I'll start by making a rough sketch of the kite. Now that this is a rough sketch, I could have put C up here and A down there, but it doesn't make a difference. Now the gradient of BD is positive and it's 3 over 5. So the correct orientation of this kite should be something like this. But again, it doesn't really make a difference. I just want to see where the points lie relative to the rest. I'll start by using this formula and create an equation to find K. So using the gradient of BD, which is given as 3 over 5, I'll create the following equation. 1 minus 7 over K minus 8 is equal to 3 over 5. So minus 6 over K minus 8 is equal to 3 over 5. Let's cross multiply. Minus 30 is equal to 3K minus 24. So minus 6 is equal to 3K. So K comes out to be minus 2. Next, I will find point M, which I labeled as the midpoint of BD. The formula for the midpoint is the following. So I get 8 minus 2 over 2, comma 7 plus 1 over 2. You simplify, you'll get 3, 4. And finally, because for a kite the diagonals are perpendicular, AC is perpendicular to BD, and I'm going to use the following result. So the gradient of AC is equal to minus 5 over 3. So now I know the gradient and a point on the line AC, the point M. So y is equal to mx plus c. M is minus 5 over 3, x plus c. Let's substitute the x and y coordinates. So 4 equals to minus 5 over 3 times 3 plus c. So c comes out to be 9. So the equation is y is equal to minus 5 over 3x plus 9. But I want it in a different form. I want all the coefficients to be integers. So I will multiply by 3. So 3y is equal to minus 5x plus 27. And I want the x and the y to be on the same side. So 5x plus 3y is equal to 27 is the final answer in the required form.